Hello. In 2011, Coca-Cola has started its new marketing campaign for Christmas. They have designed a new famous white polar bear can. The can became famous not for the marketing success of the campaign. What happened is customers refused to like the product. Sales went down, and hundreds of thousands of people all over the world have flamed Coca-Cola for changing the recipe of the drink. Actually, that was not true. Coca-Cola claimed that they have never, ever changed anything in the recipe of the beverage itself, and it's just the can. But after a few weeks of actually trying to change people's minds, they have released a new red polar bear can. Why that happened? Why so many people refuse to believe Coca-Cola? Well, they were victims to something we called attribution error. They were used to having a different type of beverage inside the white can. In their brain, they associated a white can with a diet beverage, and they honestly believed that whatever they drink from a white can tastes differently than things drunk from, or the beverage drunk from the red can. Well, uh, there is a whole science which tries to understand phenomena like this. And today I would like to talk with you a little bit about why we humans make errors and what do emotions have to do with it. We'll first define a little bit what cognitive bias is, then I will try to guide you through the information processing in our brain and how do we process emotions. Finally, I will talk a little bit about decision-making process, and then I will try to give you a few hints on how do we deal with problems like this in crisis situations. If it works there, probably it will also work for you. So let's get started. This is something developed by researchers John Manoogian and Buster Benson as a cognitive bias codex. This is a classification of currently known cognitive biases. It's something between 180 and 200, and the tree is being updated quite regularly. You can find it on Wikipedia should you wish to investigate the whole thing. They have decided there are four basic types of those cognitive errors, and one may wonder, how did it happen that we actually have so many mistakes built into our brain? It's really important to understand that cognitive bias is not a mistake, it's a survival trait. Those are things which helped us to get where we are, and they're still helping us today. But as with every tool, they have their advantages and disadvantages. Let's have a look at each of the categories. When the authors decided that cognitive errors are a result of too much information, what our brain does is actually simplifies the information to make it easier for us to process it. Sometimes we just cannot easily understand what happens around us. We do not have the complete picture, we do not have the story. So we fabricate the data in our brain to make it easier for us to understand it or to process. Sometimes the decisions need to be made very quickly. In all those cases, we just simplify the whole thought process. We do not devote ourselves to investigating all possible details. Well, and sometimes we just have too much to remember, so we need to select the data. How that looks in practical situations, real life. When we talk about simplification of information, we usually choose the strategies of paying more attention to things we are primed to. If we are asked by an illusionist to pay attention to a ball in our hand, in his hand. Then we'll pay attention to a ball and miss the crucial part of the trick. This is how they do illusions. They steer our attention. We also pay attention to things which stand out, which change. Those are things which helped us, those are traits which helped us to survive in the past. Things which stand out or got changed could have been dangerous. Those of us who didn't pay attention to dangerous things never left any descendants. They died out. The same things goes for funny or fitting. They just bring our attention easier. When we talk about process simplification, we quite understandably prefer things which cause an immediate threat. That's quite obvious. But process simplification sometimes deal also with things like probabilities or avoiding things which are irreversible. We just prefer softer solutions which give us some options in the future. In terms of data selection, we prefer to choose data which is simpler and fitting our initial hypothesis. This is a very dangerous mistake. It's a confirmation bias. This is how we call it. And we also choose things which are familiar to us. It's much more easy for us to notice things we have seen before. In terms of data fabrication, we just tend to build up stories. We see them when there is none. This is how we actually see all the constellations of the stars. There is nothing like those constellations. They just look in a certain way, and we add those dots together and create a shape which is not there. Sometimes we also use labeling or assumptions as means of fabricating new data, new meanings of things which are not there. Now, a few words about information processing. We will use the example of visual sensory input. So whatever we look at creates a data stream. That information goes deep into our brain, into an organ, into a part of the brain which is called the thalamus. It's one of the oldest part of the brain, sits right in the very middle. It's a relay station. It decides where the information should go from there, redirects it, distributes it to different regions of the brain, which, evolutionarily speaking, should get the information. That information goes to visual cortex if this is a visual stimulus. Of course, if that would be auditory, that would go to auditory cortex. And in this sensory region, we just make sense of what we see. We create an image. That image is then being sent to prefrontal cortex. It's our decision-making center, which decides what do we do with the information that we have just got. Well, the situation gets a little bit more complex when we put emotions into action. The beginning is exactly the same. We see something, and that information goes through thalamus. But thalamus also sends information to a region in the brain which is essential for emotion processing. It's called amygdala. It's a bilateral organ located very close to thalamus in one of the oldest, deepest parts of the brain. Very well known role of amygdala is fear response. This is why I use this example, but it's not the only role of amygdala. They play a significant role in processing of almost all of the emotions. So once the information that we see, the picture that we notice is threatening, and amygdala will make that decision based on previous experiences, patterns, its state of activation. It initiates something which is called fear response. That fear response creates modification in actions of different regions of the brain. So amygdala would send some stimulation or inhibition to both decision making part of the brain, which is prefrontal cortex, or to sensory regions. At the same time, amygdala would also stimulate the physiological regulatory centers, which regulate our heart rate and breathing rate, dilate our pupils, make us sweat, create that funny feeling in the guts when we feel excited or nervous, or when we feel any other emotions like joy or lust or disgust. By the time the visual information, marked here in blue, reaches visual cortex, that region of the brain is already primed by amygdala's fear response. And we will actually see something different than if that stimulation didn't occur. An example of this would be that we see someone in a dark alley taking something out of his pocket. And if we're not stressed, if we feel safe, we know this guy, we recognize him, or we consider him our ally or our friend, we are more likely to recognize the dark object that he takes out of his pocket as his wallet or a gift for us, perhaps also as a gun, but the probability of this event is slightly lower, and we have all the options we can analyze. If the visual cortex and prefrontal cortex are being primed by fear response, we are much more likely to recognize this object despite having the same visual clues as a threatening object like a gun or a knife or anything of this sort. Okay, now a few words about decision-making process. It's not very complicated, it's actually quite logical. First we have data, then we analyze the data, we produce some sort of the output, and then we evaluate the situation. In terms of data acquisition, we have two typical modalities. One would be pattern recognition. We look at things and we recognize them, and that's enough to initiate the analysis in a special process about which I will talk to you in a minute. But we can also, of course, consciously evaluate this stuff. This is what we do when we encounter a difficult problem, something we haven't seen before. We just carefully look at the data and the visual data, the picture or a scene, and try to make sense of this. How does it work? Let's have a look. How many squares do you see? Most of you will actually see two white squares. Well, if I ask you how many black circles do you see, most of you will say 4. Now, this is what pattern recognition is. Now, and priming, by the way. Now, if I tell you that no, there is no 2 white squares, there is only one, that bigger one, and there are no 4 black circles. There are those strange, almost circular shapes being really 3/4 of the black circle, which make a suggestion that there might be a second square, but there is none. Well, you see that now? This is the conscious evaluation. Both of those patterns are okay. Both are needed. One works quickly. Those are the patterns that save lives. Well, the other one is the pattern which creates science. Well, most of you would be probably familiar with Kahneman's model of thinking, a famous book by a Nobel Prize winner, or a recipient actually. Daniel Kahneman have suggested that we have basically 2 models of thinking. Model 1, fast thinking, is a reflectory, low energy investment, quick working model. This is something which helps us to get from home to work every day in the morning without even remembering how we did it. This is how we spend a significant portion of our time. When we walk through a shop selecting things we would like to buy, we do some thoughtful processing about what's in the fridge. We try to remember stuff, but most of the actions we take, like opening the doors, walking from alley to alley, even paying or waiting in the line, that's done on autopilot. This is Kahneman's Model 1. This is also the same model which we utilize in case of a threat. This is what we do when we need to act very, very quickly. Reflectory action is guided by Kahneman Model 1. Kahneman's Model 2, well, that's careful, deliberate, full of reason, analyzing data and trying to come up with best possible solution. Thanks God, humans got the ability to switch between those two models, and this is what we frequently do. And actually, being skillful at this can help your decision-making process a lot, because you are just not forced to use one model and stick to it for the whole decision-making process. Based on the outcomes of action of those models, we actually either get an automated reaction based on a heuristic decision on some common sense and rudimentary logics or reflectory action, or we have some rational, mindful decision-making process. Keep in mind that both are needed and both are okay. Well, what happens then? We constantly anticipate what will happen. Our brain is a wonderful tool for future prediction. Every time we do something, we predict the outcome. When you listen to me, you also try to predict the outcome. Yes, you predicted the word correctly. In case you wouldn't, you would feel a little bit strange. In reality, this is something which helps us to see if we are in danger. If predictions about the world are not meeting our expectations, we might start the fear or fight response. Everything which happens to us undergoes some degree of memorization. It's not necessarily that we memorize all that stuff. Some of this becomes part of the patterns and heuristics that we already have. This process is actually learning. You might have used that a few times in the past. So, what factors do we know that do influence our decision-making process? I will now try to utilize the perspective of behavioral biology. Everything starts with which species do we belong to. It's quite obvious that things which cause one reaction in humans might create a different reaction in a gorilla or in a lizard. You must keep in mind that part of this is because we evolved, as we tend to think, higher than monkeys or lizards. But part of this is not because of how advanced we are, but that we are just different. So if you take two different species of fish and you present them with the same stimulus, they might react totally differently. Some of this is a result of our genes. Some of this is about inheritance of the behavior. Our children copy parents, and that's true for a lot of species. Of course, it also does matter what happened to us during the whole life of us. Did we inherit any mutations from our parents? Which environment are we in? Our decisions will be different if we are in a very mountain, rocky area with low temperatures, low sun, somewhere high in the mountains, or very harsh environment. And our decisions might be different if we are in very friendly, warm full of food and shelter environment of, let's say, a Middle European forest or a city, for example. But that I have problem with deciding whether it's a hostile or friendly environment, but surely different from a forest. There were some other things which actually might have an influence. There was a very interesting study done on children conceived right after Second World War in the Netherlands. There was a huge hunger there. There was a big shortage of food, and a lot of mothers didn't have enough food to properly nourish their kids and to maintain proper glucose levels. They have followed those kids through life, and disproportionately huge number of those, despite the fact that the shortages of food fairly quickly were corrected with a support from Allied forces. So they didn't last long. They mostly didn't last longer than the pregnancy itself. So the kids, after being born, never suffered from hunger, but yet they almost all of them developed obesity. So the logical conclusion is that whatever happened in intrauterine life during pregnancy have influenced their bodies in a way that they just deal with hunger and satiety in a very different way as compared to kids or to people who never suffered from hypoglycemia before they were born. Of course, what decision we will make is also influenced by years, but by things which happened years before we make that decision. Our cultural environment, our experience, education and training, what happened to us as children. Did we have a safe environment, or perhaps we were neglected or threatened years ago? All of that will have an influence on the decision we make today. Of course, what happened to us days and months before also matters. Recent events. Did we fail at doing the similar thing days ago? Or is it first try that we do it? Or perhaps we succeeded last time? Are we under some chronic stressors? Do we have a difficult time? Perhaps this is a professional decision which is really, really important. Not because this particular decision is very difficult, but because someone put a pressure on us over a period of recent weeks or months. Of course, our nutritional status also matters. Are we malnourished or are we obese? Maybe we didn't eat well enough and we have some vitamin deficiencies. All those factors will influence the decision that we make, the same way as things that happened minutes or hours before. What's the time of the day? Do we feel healthy? Are we healthy? Do we have any cognitive disorder today? Do we feel safe? Or do we feel that our close relatives are under some sort of a threat? What led us to this particular moment? If you imagine two fighters standing in front of each other being prepped for a really important fight, depending on how they got there, who is the champion and who is the challenger, who will attack first, who will attack second, who will defend and who will be aggressive. All those things do matter in those tiny tenths of the seconds moment that they will make the decision about next action. And of course, our current status, what emotions influence us right now. Are we sad or joyful? Perhaps do we feel disgust or lost? That will influence our decisions surely. And also hormones and glucose level. Are we tired? But things like temperature, perception of safety, and the amount of light also play a role in that process. All those things that I have just mentioned influence in some way the pathway that I have depicted to you when I talked about analysis of stimuli and emotions. So, if those things are so complicated, can we do anything about them? Until recently, literature was very skeptical, and a lot of people said that it's close to impossible to debias people. It was heavily investigated in aviation industry, in medicine and military, and also in business. That cognitive biases is something which we cannot easily deal with. But there are some recent studies which actually claim that we can reduce cognitive errors by 30%. It's not that those new studies neglect or diminish the role of the previous ones, but they do differ significantly. Both of those groups of studies are scientifically sound. What has changed is training modalities. So we have developed better training, and now we actually can influence cognitive errors and emotional control, emotional regulation, as it probably should be called, and we can improve our decision making. Some of the training that we should undergo is very error specific. So you train differently for attribution error than for neglect or data fabrication. Of course, that would mean that to improve our decision making by 30%, we should go 180 trainings. Thanks God it's not that way. Most of us do not make all those mistakes just because we are not in a situation where those mistakes could be made. Area-specific cognitive error maps should be developed because it's highly probable that a pilot will have different tendency to make those errors than a surgeon, a taxi driver, a shop assistant, or a manager in a company. What we are quite sure is that by individual training we cannot go much lower than that 30%, at least not at this moment. And since it took us a very significant amount of time to get to 30, it might get progressively more difficult to lower that more. The problem is that we need to have correct decision-making strategies today. I mean, we already should have them years ago. So what can we do? And here is something which I would like to propose. Based on the fact that each of us is different, each of us might have different cognitive biases, handles emotions in a different way. If we properly compose the team and properly train the team, we might create a situation where mistakes or cognitive biases, because they are not mistakes, cognitive biases, have a tendency to nullify themselves rather than exaggerate each other. So if we make sure that we share the information and every team member knows everything which is essential for decision making, if we make sure that the process of decision making is not only shared decision but also informed shared decision and fully transparent, so that everyone knows not only why the decision was made but also how it was made, so that the process can be questioned, then if we create an environment which is safe, where people feel responsible for not agreeing with whoever makes the decision, and we compose the team properly, we have some chances. There are a few things I explain, for example, to my residents, that it's absolutely okay for them not to agree with my decisions. What I would like them to remember is that if I don't agree, they should ask, they should make me aware that their cognitive process is different to mine. There are two possible outcomes of this. One, I still will believe that their process is inferior to mine, and I will explain to them, and they will learn. But there is another outcome, from my perspective, much more important. They will make me aware of my cognitive bias, because it's easier for them to see that bias than for myself to notice this. And they will actually save someone's life and my medical license. So this is something I strongly encourage. Now, once we have a team which is properly composed, and it's probably worth mentioning what do I mean by proper composition of the team. We still live in a paradigm of a team which is composed of unique competencies. So like we need one surgeon in a team, one anesthesiologist, one anesthetical nurse, and so on. This is very wrong thinking, because in this team there is no overlap of competencies. It's highly unlikely that I will question the decision of the anesthesiologist, and it's a huge mistake. It's probably also unlikely that anesthesiologist would question my decision. There needs to be another person with competencies at least remotely close to mine. It can be less experienced, but trained. And only then they can understand my thinking process, and they can judge it based on their own cognitive biases. It's also important that the team should be diverse, because the more diverse we are, the broader the perspectives, the more opinions we have, and actually the more different cognitive errors we might have, and they have bigger chances to nullify themselves. It's also important to remember that part of this diversity is also experience. It has been researched very well that with growing expertise, we tend to rely more on Kahneman's model 1, the reflective, the one which is actually more prone to cognitive biases. It's one big cognitive bias, actually. It usually works nicely. Well, this is why we call those people experienced, but not always. People who are freshmen, who are not experienced, do not have the input for cognitive model 1, for Kahneman's model 1. So they have to rely on logic, understanding, and analysis. So actually, their weakness might be their strength as a team member. They just do not have the input for Kahneman model 1, and they have to use Kahneman model 2, and hence the capabilities of the team get much wider. When we talk about training teams, we must remember that a lot of training focuses on error prevention. We have all those checklists, all the other stuff which helps us to memorize stuff like mnemonics to prevent the errors. But there are things which are equally important, or perhaps even more important. It's early error identification, because sooner or later we will make an error, and we must be capable of seeing our own mistakes. And we need to have means for recovery from those mistakes. And those three things need to be trained to a team. What is also important is that we train team leaders properly. Not everyone will become a good leader of the team, but most people can become capable, good enough. But we must train them not as the expert in the area which the team deals with. We must train them in being experts at how to run the team. It's not that a surgical team needs a surgeon as the lead. Anyone can lead the team, provided that person can create an environment in which a surgeon in team can thrive and make good decision. Equally thrive as every other member of the team. This is what will create a fully functional, good team, most resistant to all the cognitive bias and emotional influences. Well, my lecture might seem a little bit pessimistic, that we are very close to being puppets and we have no free will and everything depends on what happened ages ago. It's not that bad. Keep in mind that understanding cognitive error is important. understanding what we do under the influence of the emotions and how to feel that we are under the influence of the emotions is important. But becoming a robot, not feeling any emotions, is not good either. We will not regain free will because we will have no will at all. Science has proven that emotions are actually needed, if not for anything else, then at least to know when we are right. People who have injuries to brain and who do not feel the emotions or cannot perceive the emotions that they have actually cannot make any decision. They just don't feel which decision is right, and they keep thinking and analyzing stuff, and cannot come to any conclusion. So I would strongly encourage you to investigate that area, to understand all the strings you're attached to, because in the knowledge, training, and understanding, there is certainly much more free will than in sticking to our current status. Well, should you be interested in this topic, feel free to reach out to me and I will gladly discuss any of this stuff with you. You might also leave a comment, and I will do my best to answer. Thank you very much. Have a good day.